All right. So today I want to talk about scheduling and how important I think it is to the future of React. But actually, there's a little bit more to it. I think scheduling is just as important to the future of the web in general, and that the benefits of scheduling aren't exclusive to React or any specific library. I think that embracing a scheduling-first approach is going to enable us to do a lot more than we've historically been able to do. And I think that it's going to help us solve some long-term scalability problems on the web. I also want to talk a little bit about how the work the React team is doing has been helping make this a reality. So first off, let's just quickly define what a scheduler looks like. So scheduling itself becomes important when there's some kind of resource that a system needs to share. In general, a scheduler is kind of like this black box machine that makes decisions for a system about some resource usage. As input, it takes requests, and as output, it decides which of those requests should be prioritized and acted upon. Making these kinds of decisions requires a scheduler to be aware of all of these possible consumers of that resource, as well as all of those incoming requests, and any environmental factors that might affect its decision-making. So on the web, the resource that everything is fighting over is CPU time, specifically time on the main thread, which is where all of the most important things a browser needs to do happen. And that includes executing our code and updating the UI. And that means if we block this main thread by executing long-running tasks, then we can end up also blocking the browser from updating the UI, which leads to lag and really terrible things for users. If we model our code in a way that lets us split up potentially expensive work, then we can use a scheduler to help prioritize the right things and avoid blocking the browser from doing other more important things. You might have heard people refer to this feature as time slicing. For React, this was one of the motivations behind React Fiber. It was a rewrite that enabled React to split up that expensive work and use a scheduler to keep the application interactive. But is this the right solution? If you're skeptical, this might be one of the first questions that comes to mind. Is scheduling valuable in and of itself? Or is it kind of just a Band-Aid on the problem of performance for React? If React itself was just faster, would we really need a scheduler? After all, you don't have to split up expensive work if you never have any in the first place. So instead of introducing a lot of complexity and overhead to add a scheduler to React, why not just make React faster? This is a fair point, and it's true that there is some inherent overhead to scheduling, but I think the approach of focusing on raw speed, how fast we can make our code, doesn't capture the entire picture of what makes a good user experience. I also think that focusing on raw speed by itself is short-sighted, and it doesn't solve our problems in the long term. To dive a little bit deeper into that, I want to step outside the programming world for just a second and talk about this thing called Parkinsons Law. So Parkinsons Law is this old saying that you typically hear in the context of bureaucracies, and stated formally, it's defined as work expands so as to fill the time available for its completion. In really simple terms, this just means that if someone is given a task and a deadline for a task, they're probably going to take up all the available time to complete it. And I'm sure all the speakers working on their slides right now know that that's true. This is a decent definition, but I think the way it's defined in the finance world is a little bit more insightful for us. So in finance, you'll often hear this restated as, the more money that you make, the more money you spend. This is probably pretty relatable. I'm sure this has happened to many of us here at some point in our lives. And what happens is as a person's income rises, we tend to see that their costs rise at a similar rate, which makes sense. You make more money, so you want to improve your quality of life, which itself costs more money. The consequence of this, though, is that no matter how much you end up making, you're always left with the same amount at the end of the pay period, which is a little bit risky. It makes it difficult to address long-term financial goals like saving for a house, paying off a debt. And in a lot of ways, I think this is the same problem with focusing on just raw speed. because the web has a spending problem, and it's a pretty big one. Over the years, the performance of almost everything that we use to build web apps has gotten magnitudes faster. The devices themselves, browsers and their JavaScript engines, frameworks, libraries, it's all getting way faster. But what we end up seeing is that as performance improves, the expectations for what a web application can do rise at a similar rate. As we continue to make everything faster, we're also going to take advantage of all that CPU time that we free up. And this is why focusing just on speed itself as a solution doesn't necessarily scale. Going back to the finance analogy, imagine if you were experiencing those budgeting issues. So you go to a financial advisor, and they just tell you, go make more money. It's not a terrible idea, and if you can do it, you probably should, but it only solves your issues in the short term. Eventually, Parkinson's Law will prevail. Now, if you realize that financial advisor is terrible and you go to a good one, what they're probably going to tell you is, go make a budget. You need a way to understand when and where you should be spending your money and what your priorities should be. A budget helps solve the underlying spending issues, which helps address your problem in the long term. And that's exactly what a scheduler gives us. It's kind of like a budget for our code. It's able to help us intelligently prioritize and organize the execution of our program. And as the complexity continues to increase, a scheduler is going to help us manage that complexity in a more scalable way. Ignoring this problem, I think there's another big problem with focusing on just raw speed. And to explain this one, I like to think about it in terms of buying a car. I drew that, isn't it? Isn't it great? I traced it, I lied. So when you go buy a car, the first question you ask probably isn't, how fast does it go? Right? Speed is definitely important. We got to keep up on the highway, but we expect that almost all modern cars are going to be fast enough. What we tend to value are the other aspects of the car that also contribute to the total experience of driving. And those are things like safety, comfort, handling. We want nice features like cushioned seats. We want power steering, radios, airbags. And that's because speed alone doesn't define the driving experience. It's important, but it's only part of the picture. Interestingly, the features we tend to value even work against the speed. I guarantee you, if you remove the chairs and airbags from your car, it'll go a little bit faster. But we don't do that because we don't prioritize speed above all else. We're willing to make concessions when we think it'll benefit the experience as a whole. I think this holds true for web applications as well. Speed alone doesn't define the user experience. We have this expectation that they should be fast enough, but once we've met those expectations, other things become more important. Focusing just on speed gives us diminishing returns relative to other aspects of the user experience. One major factor that affects the user experience is that web applications don't just run code in a silo. They need to send and receive data over a network. And no matter how fast our code is, we can't make the user's connection any faster. Which means our applications are often bound by network speed, not CPU speed. So if we're updating our UI with some new data, we're probably spending most of the time waiting on the network. This becomes even more important as we continue to adopt techniques like code splitting, where we end up fetching a lot of our code and data asynchronously in response to some user action. As we split up more and more of our application, we now have the responsibility of coordinating all of those async updates. And if we don't, we run the risk of multiplying that network effect and significantly hurting the user experience by introducing jumpy updates, cascading spinners, all that stuff. And it doesn't matter how fast we make our code. We need to be able to account for variable network conditions and the non-determinism that comes with that. And that's inherently a scheduling problem. It's all about coordination, which is exactly the kind of problem a scheduler is meant to solve. By modeling your application in a way where a scheduler can coordinate these updates, you can provide a better user experience that's optimized for the current network conditions. And what a scheduler does really well is optimize for perceived performance, which we have to remember is always the end goal here. It doesn't matter how fast your code is if your application feels slow. And an interesting thing about perceived performance is that fastest isn't always best. And that might seem a little counterintuitive at first, but if you think about what happens if you prioritize speed above all else, you can see that it might actually hurt the user experience. So when we're dealing with a bunch of those network-bound updates, we don't know when or in what order they will resolve. It's very likely there will be noticeable gaps. And if we prioritize showing those updates as fast as possible, then we're most likely going to be updating the UI one piece at a time. In a lot of cases, this means the UI will jump around and load in an unexpected, oh, there's my mouse, an inconsistent order. There, I found it. Even if this happens really quickly, it can feel slower because users notice all of those intermediate loading states, which means it can actually make sense to delay updating the UI if you can commit everything at once. And since a scheduler's primary purpose is, again, coordination, that's exactly what it lets us do. Assuming we don't delay for too long, this can actually end up feeling much faster, which again is a little counterintuitive, but the reason this works is because of something called just noticeable difference. So just noticeable difference is the amount something must change in order for a difference to be noticeable. This is a really important idea in the psychology of perception. And what's been found is that for almost every kind of perception that we possess, there is some threshold where we can't really tell the difference between two things that are very similar. And a classic example is our sense of weight. If you were handed two weights, one that weighed 10 kilograms and then another that weighed 11, you probably wouldn't be able to tell the difference immediately. That 1 kilogram difference would likely be just below your threshold for your perception of weight. But also, if you were handed a 1 kilogram and 2 kilogram weight, it would probably be much easier to tell the difference. That same 1 kilogram difference is more noticeable. And that's because that threshold is dependent on the scale of things being compared. Now, the reason that this matters for scheduling is because this also applies to our perception of time. We can't really notice small differences in time. And that threshold for what we can notice scales up as the durations get longer. And this is a fundamental aspect of our perception. And since we're trying to optimize for perceived performance, it's something that we can take advantage of. This is what allows us to delay committing updates without noticeably affecting the user experience. And since this threshold is relative to the duration, that means we have a lot more wiggle room for things that are expected to take longer. So for updates that should feel immediate, like clicking a button or typing in a text input, we don't really have a lot of time to delay before the user notices something. But for things like loading data over a network, where they might already expect to wait a second or two, that threshold is high enough that we can often wait for those requests to finish without noticeably delaying the update. This approach is exactly what React does at the moment. This is, of course, an implementation detail, and it might change in the future, but currently React will use an explicit just noticeable difference algorithm to determine the timing for committing updates with Suspense, where the longer we've waited, the longer we can delay committing. And this is all possible because of React's scheduler. Now, a lot of the benefits that a scheduler provides are due to the fact that we can define explicit priorities to the work that we're scheduling. So when our application schedules some work, the scheduler needs to know how important that work is. This is part of the scheduler's decision-making process when determining what should happen next. So for React, the different priorities look a little something like this. So starting at the top, we have these immediate and user blocking priorities, which both essentially mean do this thing now. And the difference is that immediate can be like synchronous, while user blocking has a very small amount of wiggle room. And then right below that, there's normal priority, which is kind of what most code falls under. This is stuff like processing an update after a network request finishes. We want these things to happen soon, but again, we have a little bit of wiggle room. They don't have to feel instant. And then there's low priority, which is things we want to happen, but we don't really care when. Think of things like logging. We want our logs to be sent to the server, but it's okay if they're delayed for a while, as long as it eventually happens. And then lastly, there's idle priority. This is the one that I get the most excited about because without scheduling, this category of work isn't really even possible. Idle priority captures things that we'd like to happen, but we don't really care if they don't happen at all. These things can be delayed indefinitely if there's never an opportunity to do them. So this is the kind of stuff that you can do with like request idle callback, but there are definitely advantages to using a scheduler that's aware of other prioritized work as well. So here's a real-world example of how enabling developers to do idle priority work can change the way we build web applications. So recently at F8, which is Facebook's big conference, we discussed how Facebook is using runtime checks to find accessibility issues and surface those to developers in their dev environments. Coming up soon, Jonathan Young has an awesome lightning talk about this, so stick around for it. But this feature is only possible because we have a scheduler. The work required to check all of the elements in the DOM for all the possible accessibility issues is inherently expensive. It requires traversing up and down the DOM, querying and analyzing a bunch of attributes, and a bunch of other complex things that you just have to do. And trust me, we made it as fast as we possibly could. But without a scheduler, we still ran the risk of blocking more important things like user input. It would work fine, we found, if there was only a handful of elements to check on the page. But as that number of elements scaled up, so did the runtime, and eventually we'd reach an inflection point where running the checks could cause noticeable stutters or delays. And while this is only a developer-facing tool, those delays are still unacceptable because it might affect the work that they're doing. But when we refactored this to take advantage of a scheduler, those delays stopped happening. We found that no matter how many elements we needed to check, higher priority updates like user input were never being blocked. Scheduling enabled us to scale this at an entirely different level. Okay, so I hope it's clear that we get a lot of value out of scheduling. It provides a scalable solution to the problem of performance by giving us a way to budget and prioritize the code that we run. It lets us coordinate both CPU and network-bound updates, and by doing so, it gives us a way to improve perceived performance as we can potentially reduce the number of loading states, providing a better experience. Scheduling also gives us a way to do low-priority work without having to worry about blocking other important things, which can enable new tooling and patterns. I also hope it's clear that the problems that we've outlined and the solutions that scheduling provides aren't unique to React at all. We honestly haven't even talked about much React specific yet. And that's because scheduling doesn't solve React problems, it solves UI problems. Everything we've outlined here is equally relevant to all web applications, no matter what their source is written in. We all have to deal with increasing complexity, coordinating async updates, and improving perceived performance. So if we agree that utilizing a scheduler is beneficial, then the question then becomes, where do we go from here to make this a reality? What needs to happen to enable our current and future applications to utilize and benefit from scheduling? So as we know, React itself is already working towards this. It has an internal scheduler, which will bring all of these benefits to React. But there is one problem. React doesn't control all of our code. Even in a good React application, React can schedule the things that it's responsible for, like updating state and rendering, but we're also likely executing code that's outside of React's control, code that might be expensive and make it difficult for React scheduler to do its job. We might even be using React alongside another framework that potentially has its own scheduling needs. And when you look at this problem, I think it quickly becomes clear that we need coordination in this space. Because if scheduling is going to be a big part of the web's future, then we need a way to coordinate between different parts of our application. And in order for a scheduler to be efficient, it has to be aware of all the work that's being done on the page. That's a key component to its decision-making process. So if we end up with a bunch of different schedulers working independently, or with a bunch of code that's not even being scheduled, then we're not really going to see the same kind of benefits. Now, the React team has recognized that this is a problem, and they've made progress towards solving this in a more generic way. They've intentionally designed React Scheduler to be independent of React. And the current intent, as I understand it, is to publish the scheduler as a standalone package that React itself depends on, so that any other code can use the same scheduler alongside React, or even without it. And this will be a potentially huge win for the web community in general. Having a generic scheduling library is a great first step towards making scheduling efficient and accessible for all of our needs. Using the same API reduces cognitive overhead, it allows our code to be portable, and it gives us the best chance of efficiently scheduling all of our work, since the scheduler is aware of everything that it needs to know to make its decisions. Except that it's actually not at all aware of everything it needs. While it's important that a scheduler is aware of all the code that we want to execute, there are a lot of other things that a browser does that might affect its decision-making. And this includes things like garbage collection, the current frame timing, and any rendering the browser is already doing. The code that we execute is only one part of the picture. So a scheduler that's implemented completely in user space is always going to have incomplete information. And that's why we need better scheduling primitives for the web platform. We need the browser to either provide a full-featured scheduler or at least give us APIs that provide the necessary information to our schedulers so that they can work efficiently. As it stands, we have a handful of APIs that we can kind of use to cobble together a working scheduler, but ultimately they don't really provide any insight into the current state of the browser. Luckily, this problem is being actively worked on. The Web Platform Incubator Community Group, or a WICG, it's a group associated with the W3C standards body, and they are currently thinking really hard about this problem space. There's this amazing repo on their GitHub page that provides a fantastic outline of all of the current problems with scheduling on the web and some potential solutions moving forward, so check that out. Teams like Chrome at Google and the React team at Facebook and other browser and framework authors are also collaborating in this space. To me, one of the most exciting developments is the recent work done on a new API called isInputPending. This is Facebook's first API contribution to the browser, and it's a direct result of the work that teams at Facebook and others have been doing around scheduling. What it does is allow a scheduler to very quickly check if there's any potential input events, like mouse or keyboard events, that the browser has to respond to. If there are, the scheduler can yield its time back to the browser and let it handle those events. Otherwise, it can just keep processing all of the other scheduled work. Without this, a scheduler always has to periodically yield to the browser to check for those events, which gets pretty expensive when you have to do it at that frequency. So this API can let a scheduler make more informed decisions. It's a great example of how the web platform can enable user space schedulers to work efficiently. But it's just one piece of the puzzle, and there's a lot more that can still be done here. Though I expect that we'll see more APIs like this in the near future. Lastly, I want to talk a little bit about what we can do as product developers to start thinking about our code in terms of scheduling. There's not a lot we have to do, thankfully, but there's a couple of important things to keep in mind. First off, don't be this person. We've probably all done it, and we're all going to do it again, but this idea that your thing is the most important thing can be really bad for a scheduler. And Z-index is a lot like a priority, right? And if everything is high priority, then nothing is. And that's a big problem for scheduling. And then lastly, we want to keep thinking about how we can make things as fast as possible, but we should also start thinking about how we can break up and schedule our more inherently expensive work. In order to continue scaling and increasing the complexity of our applications, we're going to need to do both. And that's everything. Thanks for listening. You can find me on Twitter at @aweary. Thank you.